This is my game called Shroom and Doom. Shroom and Doom is about an office worker called Owen who has lived an extremely mundane and comfortable life. However, this all changes when a zombie apocalypse arrives. Owen realises that he'll be soon eaten by a zombie, and looking back at his boring life, he decides now he'll change and reinvent himself. Owen takes copious amounts of magic mushrooms, runs outside and takes the fight to the zombies, which all now have brightly coloured hair, and Owen can now shoot magic blasts out of the staff because he's a wizard. Here is the main function of the program. First, the background music is played, then the game loop, main menu and game over menus are created. The main menu is updated and rendered until the player presses enter to start the game, which runs the game until the player dies, and then the main menu is shown. If the player doesn't close a window, then this loop will repeat. When the player presses the close window button, the game calls its clean and uninitialized functions to free used memory, and the program closes. Here's the Vector 2 class I created for the project. The player is able to move around the map, which is an 8x8 grid. The player moves by inputting a direction using WASD and then clicking the mouse to move one space in that direction. I created a grid class which handles a lot of the complexities of working with a grid. The class can store the state of each cell with a 1 or a 0, 1 being able to move to and 0 being something's already in the cell. The grid can be rendered as a grid of lines, the grid can convert pixel coordinates to grid cells and vice versa, the grid can highlight specific cells, and the grid can get a cell using a cell coordinate and a direction, which will return the next cell in the given direction from the cell given. To move the player in the update function, we first get the inputted move direction, then it updates the sprite sheet animation to be facing in the correct direction, then the cell the player is going to move to is highlighted, then whenever the player clicks their mouse, the move function is called, which first converts the pixel coordinates to grid coordinates, then we can get the adjacent cell pointed to by the WASD keys and convert this back to pixel coordinates. We can then update the last location and location variables to move the player. Back in the update function, we'll add some code so the player loops around the screen when exiting the bounds of the screen. Every frame, the zombie spawner runs the check player collision function, which returns false if the player is not colliding with a zombie and true if they are. If the function returns true, then the game exits the game loop and goes to the end screen. I wanted the shooting to be automatic. The player should move the character around, and the character will automatically shoot at any zombies it's close to. To do this, I'll have to check the distance to all the zombies every time the player moves, and so I'd need the zombie spawner to know when the player moves so it knows when to check the distances. To accomplish this, I use the observer pattern. This is where you have a subject and observers. The observers will subscribe to the subject, and when any interesting events occur, the subject can notify all of its subscribers. The great thing about this is if more classes need to subscribe to the subject, they can without having to edit any of the subject's code. The player inherits from the iSubject interface, which has the register observer, remove observer and notify observers virtual methods. The zombie spawner is an iObserver, which inherits the observer update method. When the zombie spawner is instantiated, it registers itself as an observer of the player, which adds it to its list of observers. Then when the player moves, the notify observers function is called, which calls the observer update function on all observers. For the zombie spawner, this means getting the closest zombie, finding the distance between the player and the closest zombie and its magnitude squared. We use magnitude squared as it's quicker to calculate than magnitude. We check if this magnitude squared is less than a certain threshold, and if it is, the zombie spawner notifies its observers. This means that the bullet manager will have its observer update function called, which will shoot a bullet. The bullet will have a vector 2 direction and a position. Every frame the bullet's position will be updated, and all zombies will be compared against all bullets to look for collisions. If there is any, then the zombie will be removed, and this is how the shooting mechanics work. The game uses a tiled map, which has a map height, width, and a map, which is a 2D array made up of integers which correspond to a tile in this tile map. The constructor opens this file and reads all of its lines, inputting them into the map text array. The file is then closed, and the map attribute is iterated through, reassigning all of its values to those in the text file. Then in the init function, the tile map is loaded and the tiled map is ready to go. In the render function, the tiled map selects a tile from the tile map attribute and creates a rect in the position of the tile to be drawn, and renders a copy of the image from the source rect. This is done for all the positions in the tiled map. When a bullet collides with a zombie, the bullet manager calls the game manager's increment score method. To display this score, I have a game UI class which will render the score from the game manager on the screen. To do sound, I use an external library called Mini Audio. When the program starts, a new MA engine is created, and if the engine initializes successfully, then the MA Engine Play Sound method can be used to play a sound when given a file path. This plays the music for the game. And in the player's init method, another audio engine is created, which can be used to play the movement noises. Every time the player moves, this sound is played. The game has a particle system, which makes it look like it's snowing. This is done by having a particle class and a particles or emitter class. Here is the header for the particle class. The game saves high scores in this file and can display high scores. You can see the high score on the main menu, and you can see it on the game over page when the player dies. The game uses object pooling as optimization. When the game first starts, a loading screen is displayed, then the zombie spawner instantiates and initializes 63 zombies and stores pointers to them in a zombie pool vector. Then when a zombie needs to be spawned, a zombie is popped from the back of the zombie pool and pushed into the zombie's vector. Its position is also set to be a random grid square. Then when the zombie dies, it's removed from the zombie's vector and pushed back onto the zombie pool and moved off screen. When the game is to be reset, the zombies in the zombie vector is moved back into the zombie pool, and here's the performance metrics of the game running. At the start of the project, I set out to make a zombie slaying grid-based rhythm game. The player would need to be able to move around the grid, shoot zombies automatically when they got close, and the player's movement needs to be somehow linked to the song that's being played. To make this game, I used resources made available to me by my module tutor, and I did some research of my own. I found a good guide on how to make a rhythm game, and I intended to follow this guide. I made a conductor class as the guide said. However, due to time limitations, the rhythm game idea was scrapped, and instead the player moves around the grid at their own pace. Here is an internal class structure of the project. I tested my code regularly through development and used breakpoints to check that values were as expected. At a high level, the program has a main menu class, game loop class, and an end menu class. In the main program, there is a while loop which will execute until the user tries to exit the program. This while loop will run the main menu's update and render function until the user presses enter, at which point it will run the game loop's update and render function until the player dies, and it will then run the end screen's update and render function in the loop. When the player presses enter, the main menu, game loop, and end screen are reset, and this high level loop starts again. One weakness of the game is that all the zombies are spawned into the zombie pool at once at the start of the game, causing it to load for a few seconds. Instead, I should have spawned the zombie when the game is being played and only when needed, but only if the zombie pool vector is empty. If the zombie pool is not empty, then a zombie could have been taken out of the pool. This would mean the program wouldn't have to load at the start, and the program could still take advantage of object pooling. Additionally, instead of having a vector for the spawned zombies and a vector for the object pool, and having to move zombie pointers between the two vectors, I should have had all the zombies in a single array so it does not need to change size, and had a front and rear pointer or index. The array could act like a queue, as when unqueuing, the rear pointer could be increased by 1, mod the size of the array. And for dequeuing, the front pointer could be incremented and then modded as well.